Alright, it's Mr. Adcock again with another science video. Today we're looking at balancing chemical equations. This lesson actually builds off of some of the previous lessons we've had by learning how to count atoms and molecules and actually tell what's an element and what's not. So if you haven't watched those videos, you gotta watch them or you won't understand anything with this one. The overarching standard that covers this material is 7.5D. There's some other parts that it actually covers, but I didn't really have room for it up there. But we'll learn about it anyway. All right, so a chemical equation. This right here is a chemical equation. It's telling me that you have something to begin with, it undergoes a change, and then you have something at the end. So there's three parts of a chemical equation. You have your reactants. I'm just writing an R up there. You have an arrow. Guess what? It's that arrow. That's pretty easy to find, right? And then you have your product. Beginning, change, end. Does that make sense? You have your reactant, you have your chemical reaction, and you have your product. Can't remember that? Remember RAP. That's easy enough. So you also have other things going on in a chemical reaction. Of course, you have your elements. Those are the capital letters, remember? And some capital letters can have a lowercase letter with it. Why? Because there's only so many capital letters to go around. And sometimes to give something a name, you got to use a lowercase too. But we have to also look at these subscripts and coefficients. Sub means below. Script means writing. So these right here are your subscripts. And you have your coefficients. That's the big numbers. The subscripts tell me how many atoms of that element there are. The coefficients tell me how many molecules containing those elements there are. So there's 2 atoms of hydrogen in this molecule, and there are 2 molecules of that. Those big numbers are just an easy way of, instead of writing H2 and H2, you just have H4. Does that make sense? I think it does. Or it has 2 H2. It's just telling me that I have 2 molecules of that. Okay, it works good enough. All right, so does that make sense? Coefficient, that's the number of molecules. Subscripts, that's the number of atoms. Easy enough. Now we have to look at something important. There's a lot of laws. I'm sure some you've broken at some point. But today we're going to look at the law of conservation of mass. The law of conservation of mass states that matter is never truly destroyed in a chemical reaction. When you set your homework on fire at home and try and blame, I didn't have it because it caught on fire, or whatever. Whenever you burn something, you're not actually destroying it. You're just changing what state it is. If you burn your homework, well, the fire is a chemical reaction. It's causing the paper to change its state. It's burning, it's taking energy out of it, so it'll be reduced to a pile of ash, which is mostly carbon, but the rest of the paper is going to be going up in the form of carbon dioxide because it's taking oxygen molecules from the air, feeding the fire, and it's changing that paper's state to a gas. So it's not actually going bye-bye. It's just changing the way it looks. So matter's never really made. It's never really destroyed. It just changes. So we can look at this in this example, and I'll go more into it in the next one. This chemical reaction is telling me that I have carbon, hydrogen, and oxygen. They undergo a chemical reaction, and they change how they look. There's not really any extras being created, but later we'll learn that sometimes you have to change how many you put in order to get the right number on the result. So we'll get to that next. So balancing these chemical equations. It's like a seesaw. You think about it that way. You can't have one side that weighs more than this side. So if it's unbalanced, you can do something to fix that. You can change the coefficients. You can't change the subscripts. So you can change this. You can change the big number. You can't change the little number. You just can't do that. But you can change that big number. So the way you balance a chemical equation is, first off, you identify the elements you have in the equation. We have carbon, we have hydrogen, and we have oxygen. We've got to have those on both sides. Carbon, hydrogen, oxygen. Why? Because one side has those, so the other one has to have it as well. So now we go through and count how many atoms of them there are. So over here we have 1 atom of carbon. We have 4 atoms of hydrogen, and we have, remember how to do this? You take that coefficient, you multiply it into the subscript. Now we have 4 atoms of oxygen. Same thing on this side. Carbon, 1. Oxygen, 2. 2 times 1, 2. And then you add them together. That's another thing. There's an oxygen here and there's an oxygen here. Don't have CHOO. That makes no sense. You just put those symbols together and you'll add them totally. So you've got a 2 right here, and you've got 2 times 2. Makes sense? So that 2 times 2 is 4, and 2 times 1 is 2. So 2 plus 2 is 4, and then you have 2 times 2, 4. So there's 4 hydrogens. Does that make sense so far? Yes or no? I can't see your heads, but I'm hoping they're bobbing yes. All right, so now let's actually try one out. I've already labeled this one for you. So let's go through. We'll start counting on this side. So remember, you have your reactant, chemical change, product. All right, so we have 1 carbon on this side. Oh, I got it right, don't I? We have 1 carbon. I see 4 hydrogens, and I see 2 chlorines. All right, on this side, I see 1 carbon. 1, 2, 4, 1. So now I have 5 chlorines. Oh, put that in the wrong spot. 1, 4, 2, 1 hydrogen, and then 5. Do you see how I counted those? I just counted those up. But you can look at it and tell something ain't right. I've got to add some coefficients to make this balance out. So what should I do? What should I do? Well, how about I try making this into an 8? Does that make sense, maybe? Let's try that. 4 times 2 becomes 8. Well, how about 4? Wait. That would make sense, wouldn't it? It's kind of like a game. I'm trying to make both sides look the same. So if I add a 4 over here, boom, guess what? Now we have 4 hydrogens, and we have 4 plus 4, 8. Do you understand the way I did that? How I did that, how I reached this conclusion. Now they balance out. The seesaw is straight. There's the same number of reactants and products now. I just changed how many I had to add to the equation to produce the same results. And remember, you can only change the coefficients. Does that make sense? All right, let's try another one. These next ones aren't as pretty looking, so let's try that out. So let's identify a few things. We've got our P. Does anybody remember what that is? I believe that's phosphorus. Don't you, Miss Moss? She's shaking her head like she doesn't know. It's phosphorus. All right, we've got oxygen. So phosphorus and oxygen, phosphorus and oxygen. Let's count how many we have in the beginning, because this one might actually already be balanced. There might not be any work to do. That sure would be nice. So 4, then we have 10. You see how I'm getting that? 5 times 2. So now let's look at this. Oh, guess what? Boom, boom. 4, 10. These are balanced. There's nothing for me to do here. Yay, no work. Let's try this next one. All right, K, that's potassium, isn't it? Ah, it is. Potassium, chlorine, and oxygen. Potassium, chlorine, oxygen. All right, so 1, 3. 1, 1. Uh-oh. What are we gonna do? Because there's more on this side. 1, 1, 3. Let's sit here and puzzle this out just a little bit. The only thing I could change over here is this number. So let's think. There's 3 oxygens over here. There's 2 over here. That's actually a 2. So what number could I put in and see if they equal out? Well, if I did, let me think. So we can take let's try 2. 6. All right, so now we'd have to find Do you see how I did that? I just tried to figure out in my head how I could arrive at the same numbers on both sides. So let me work through this. 2 times 1 becomes 2. 2 times 1 becomes 2. 2 times 3 becomes 6. 2 times 1 becomes 2. 2 times 1 becomes 2. 3 times 2 becomes 6. Huh? Miss Moss said my math is good. Thank you, Miss Moss. Oh, this next one's a little harder. All right, Fe, I believe, is iron. Some of these are actually named from chemicals that had different names to begin with. They use the Latin name. For like iron used to be called ferrous, and that's why it's got an Fe symbol now. We took the Latin name. Ferrous and oxygen. Ooh, this is gonna be hard because there's so much math. Let's look at it. All right, so 4, 6, 4, 6. There wasn't actually any work to do, was there? Because they were already balanced. It's so easy, so easy. If there's any questions, I'll address them in class. If not, leave some in the comments, and I'll try and figure them out. Thank you.